Hello, everyone, and welcome to another Open Rewrite Community Office Hours. As always, I am Sam, our VP of Engineering at Moderne, and it's so lovely to see all of you. Right off the top, we have a few announcements. Let's see, we have been getting out there doing a whole variety of presentations. Saw some of you at DevNexus. Well, not me personally, but other Moderne employees like Jonathan would have seen you at DevNexus if you visited that. And we have been on a variety of podcasts and blog posts and YouTube videos recently. So let me share some of those with you. So the first was this podcast on front lines with Jonathan Schneider. I'll put the link to that in the chat that you can go check out, where they talked about a whole variety of things about Jonathan's background and the beginnings of Moderne and Open Rewrite. And if you really want to delve into, Open Rewrite and its history, which obviously you do. Well, this one is on Spotify, as is this one about how Open Rewrite happened, which is more specific, not as focused on Jonathan, but is focused on Open Rewrite. But there's still it's with Jonathan, and since he created it originally, his background is quite relevant. So check those out if you want to learn more about the history of your favorite open source refactoring library. We also have some new blog posts. AI continues to be a hot topic in the industry. And so this blog by Justine about deploying AI large language models in environments where expensive GPUs are not available is a must read for anyone looking to operationalize large language models in a cost efficient way. Yeah, so that's this one's really good stuff. Strongly recommend it. And from Tim to Beek, my usual co-host and person you're used to helpfully answering your questions in the Open Rewrite community Slack and Discord, we have this blog post about streamlining feature flag management with using the Open Rewrite Launch Darkly library to remove defunct feature flags and other workflows around keeping your usage of feature flags trim and tight and without cruft left over from using that particular pattern. And lastly, we have had a whole variety of new videos in the past. Well, a whole variety. There's been a couple videos in the past week or so. So there's another one about this AI visualizations video. Makes for a great companion piece to Justine's blog about the deploying large language models on CPUs. So yeah, check that out if you are interested in AI and the like. It's very cool. So today, my topic to discuss is recipe authoring kind of tips and tricks. And I'm going to go through um, maybe some of the more challenging recipes, or rather patterns that I have found in my own recipe development to be useful within more challenging recipes. And we're going to discuss things like how to write a recipe that is very responsive to what you're looking for appearing in different contexts. It's very easy, or it's comparatively easy, when you're looking to change something that is very specific and appears in a very specific way in a very specific place. But sometimes you want to be more general about it and be very responsive. Like maybe the bit of code you're interested in is over here or over there, or might not exist at all. And so we'll discuss a recipe authoring pattern for that. And then I think we'll talk about composing scanning recipes together. Composing recipes together is one of the kind of most core patterns in Open Rewrite for code reuse and for making more powerful recipes out of simpler individual components. So we'll discuss that and some of the challenges that come in when the recipes you're looking to compose together are scanning recipes. A scanning recipe is, well, we've talked about that subject before, and we'll talk about it a little more when we get to that. So, initially, the recipe I wanted to look at was, we'll pull it up and we'll pull it up in the Moderne interface to start. But it's this guy, Gradle test use JUnit Jupyter, and this was a piece of the JUnit 4 to 5 migration. This is a piece of the JUnit 4 to 5 migration, which was missing until somewhat recently. It was something that people had requested. I haven't actually run this recipe on these repositories, so we'll see if it actually makes any changes there. But this was just part of migrating JUnit 4 to 5 in Gradle, was that you needed to update your configuration of your test tasks to include this use JUnit platform method call in order to have Gradle use JUnit 5, JUnit Jupyter instead of JUnit 4 when running your unit tests. So before this recipe was in there, that was just a manual change that was required when you ran the JUnit 4 to 5 upgrade. But now this has been in the JUnit 4 to 5 upgrade for, I don't know, several weeks at this point, and uh, it's at first glance it's pretty basic, right? Like you're just adding a single method invocation to configuration of the test DSL. But the challenge is in Gradle, there's always a lot of different ways to write things. And there are many circumstances you might run into where you would want to reuse the existing configuration without clobbering it, right? Like it might be the case that that test tasks are configured with, there's no configuration of the test task, as in this case, and you might need to, add a whole new block where with all tasks of type tests, you configure each of them to use the JUnit platform as its test engine. But it might also be the case that there's a test DSL already present, in which case, in order to generate a minimal PR, which has the fewest possible changes in it, so it's as easy as possible for code reviewers to accept because it tries to seamlessly align with what they're already doing, you would rather just add the use JUnit platform configuration to the existing test task configuration rather than kind of creating a new block for it. And similarly, you might have a test block that explicitly used the old, JUnit 4 runner, in which case you'd want to replace that, right? You wouldn't want it to, come out looking, using both. I'm sure that would be, I don't even know what Gradle would do in that case, but it would probably be an error. And similarly, there might already be a task with type test, might be a task with type test configure each. You might be grabbing a task name test. You might be, grabbing a task name test with, yeah, and there might be other DSLs in there called test that are not the test DSL that we'd want to add it to. So, we wouldn't want to add a JUnit platform to this test DSL because that's configuring the source set, not actually the test task. So there ended up being a lot of different possibilities. And if you wanted to make this recipe work with all of them, uh, it took some doing. And there are more possibilities for how this could be configured than this recipe even covers currently. Um, so this was, despite the kind of simplicity of the mission statement, of just add this method invocation to the test configuration, quite a challenging recipe to write. And this took a little while to do, and I ended up finding a pattern that I have used a couple times now in kind of similar circumstances. We have the all recipe authors at this point will be, familiar with starting off the recipe by rejecting making changes in circumstances that are inapplicable or that we can't be confident that the change would be correct. So, we start off, if we can't find the Gradle project marker that is the signifier that we're operating on a build.gradle and therefore have access to its metadata, we want to return early. And we obviously wouldn't want to make this change to a project that did not use, the Java plugin. Like it'd be very silly for someone's, I don't know, C++ project that was built with Gradle to suddenly have JUnit configuration appearing in it irrelevantly. So there's the usual kind of defensive programming um, against that, and then the very first check after we have identified that we are working uh, on a Gradle project that uses the Java plugin is to check if it already has uh, a JUnit platform invocation in there somewhere, and return early if it does. And that's how we avoid the the recipe making multiple changes, or not making multiple changes, but it's how we how we avoid making any unnecessary changes or even just unnecessary computation in a source file that doesn't need it. And then there are several layers of of attempting to update the thing if it already exists. Uh, and this might be counterintuitive, or maybe it is intuitive for you. I'm not sure if I expected things to go this way. And in some sense, it seems a little bit mm, backwards to me that the very first thing we do after having determined that this is a file that we are interested in making a change to is to always try to edit the existing invocations. So we kind of start with the most incremental changes possible, and only if the most incremental change is unavailable do we, fall back. The very last kind of fallback is adding a whole brand new one. So we always try to update the existing thing first, and only if it doesn't work do we get progressively more. Mm, Aggressive isn't quite the right word, but uh, impactful perhaps with the change. We always try to make the most minimal change first, the most minimal change being editing existing test configuration rather than adding whole new test configuration before we move into that more drastic step of adding new test configuration. And you see here, so that we've, within this recipe class, and we'll get into each of these visitors in a moment, that I'm to keep the logic kind of clean and easy to follow. I made separate visitors for each kind of either updating existing test configuration, or updating existing test DSL, versus one for adding it wholesale. And so after applying each of these visitors, I do a check. And this is something that, like, you could use cursor messaging or some other communication channel for, but I found it in this case it was simple and convenient just to use a referential equality check. Right, this compilation unit field is the original LST, and because all of our LST types are immutable, it will not be changed by applying visitors to it. Rather, a new instance will be returned. And so, if this visitor runs and what it returns is different than the original, then uh, I can say that the that this visitor did its job. That it found an existing JUnit 4 configuration and updated it. And so we're done here. And only if this visitor was unable to make any changes and therefore the job still needs to be done, do we go to the next step of trying to, we couldn't find a use JUnit method to swap out with the use JUnit platform, but maybe there's an existing test DSL that we can update. And then, finally down here, do we get to when it needs to be added wholesale. And so each of these visitors, well, this function, as well as each of these visitors, kind of implemented them in their own class or method. And so there's quite a few visitors in this file, right? There's the base visitor here, but this visitor is implemented with four other visitors, each of which may be implemented with their own visitors. And it was while working on this that I kind of mused to myself that once you're used to it, the visitor pattern is much like any other form of control flow over a collection. It is conceptually not that different from looping over a stream of the elements within a complex data type. And so, just like you might as a programmer have frequently have occasion to nest loops within one another or nest recursive method calls within one another, it can frequently make sense to nest visitors within one another, and that's not really any stranger or more esoteric when you think about it. Um, so yeah, I found it keeps this much cleaner and easier to follow what's going on here to have broken this out into four or five other visitors, which handle these specialized jobs, right? Like, and particularly because almost all of these guys are using the same visit override, right? Like they're all using visit method invocation or occasionally visit compilation unit. So you can imagine if all of these four different visitors with all of their complexity, that one visits lambda, if all of these kind of like four different visitors with their various complexity were all implemented in one visitor together, it would be so difficult to read, right? It would be very hard to understand what was going on because they would all be intermixed with each other and trying to, yeah, you need a lot of control flow to parse out, when you were looking at one situation versus the other, or, just have one, an incredibly long method in here with a lot of checks. So instead, if you decompose it into small specialized visitors that do exactly one job, it gets much easier, right? So like, this first one, for contained student platform invocation is just looking for a method invocation with a particular name, and that's all it has to do. Oh, and here's a trick. Sometimes, most of the time when you're writing a refactoring visitor, you use the type parameter here on the visitor with execution context, as that is what recipes require you to do. Like if the visitor you're authoring is being returned from recipe.getVisitor, uh, there is no choice for you about what that type parameter is. It must be execution context. So you might have wondered at one point, why is there a type parameter there at all? If it's always execution context, no type parameter is needed. And this guy is an example of a time when you could write a visitor that does not have that does not use execution context as its type parameter, and instead, uses an atomic boolean for its type parameter, so that during visiting, when it finds the condition it's looking for, in this case, the existence of a use JUnit platform call, it can uh, it can set that to true. Now, in this particular case, it wouldn't really change very much if this were an execution context parameter, but because we would still be in the appropriate lexical scope in order to set this found variable directly. So I don't know, maybe that isn't the best example, but when you are recipe authoring, be aware that if you want to write a visitor that isn't a refactoring visitor, but an information extracting visitor, that you have the freedom to use a different type parameter here and have that, whatever you fill in for that type parameter pass through all of the visit methods so that you can read or write information from it accordingly. Okay, and so if we've so kind of delving into how each of these work, the first thing we try is update an existing used JUnit 4 invocation. and that one is pretty straightforward. Uh, there is some extra checking in here because unlike a Java file where we are always quite confident in the correctness of the type attribution, in Gradle scripts and Groovy Gradle scripts in particular, this is much less the case in Kotlin Gradle scripts, which we don't yet support. Sorry about that. But in Groovy Gradle scripts, there's a lot more possibility to have symbols that we are not able to type attribute successfully or thoroughly. And so this recipe does some doesn't use utilities you might be familiar with, like method matcher, which are based on having full and comprehensive type information as much, relying on context and manually checking like method names and number of parameters and types of parameters in order to establish to a reasonable, if not perfect, degree of confidence that the thing we're operating on is the thing we intend to operate on. And so, yeah, this one of updating the existing use JUnit 4, very simple and straightforward. Aside from, doing the check as to uh, make sure we're operating on the thing we think we are. It more or less just changes the name and the type information on the method invocation from the old one to the new one. So pretty straightforward one-to-one sort of swap. And then the next one is adding the method invocation to an existing test DSL. And so this guy has a little bit more complexity because again, there are many different DSLs or many different ways by which this test task could come to be configured, and we try to support at least the most common ones, right? Like there are more ways to do it than are listed here. Particularly since Gradle files are code, you could always, write really obfuscated build files that were hard to statically analyze with high confidence. But we handle the most common cases by looking at the method invocation and checking its name and its number of arguments and the types of those arguments in order to get pretty confident that this is the method we're interested in. And if it is, this passes off to another specialized visitor, which further, keeps each kind of piece of this file or each piece of this implementation responsible for one specialized thing as much as possible. And so this, add platform as last statement enclosure visitor is one that does just that. When you have an existing DSL, and we're like, well, we want to add this JUnit platform call as the last statement in it because it might already have some other statements in it. This is what it's responsible for. And so this shows us an example of how to add code snippets in a situation where you don't have Java template or a Java template like mechanism. We don't have a Gradle template or a Groovy template, but this recipe still needs to go and generate new LST elements. We need to get out a method, a use JUnit platform method invocation that is appropriate and place it in the appropriate place in a Lambda, even without the support that something like Java template provides. So what we end up having to do is more or less an inline version of what something like Java template would do in order to turn text into usable LST elements. We actually just create a new Gradle parser, have it parse a code snippet which contains the thing we're interested in, and then we extract from the resulting compilation unit just the statement we're interested in. So, all of this is just navigating into the compilation unit return from this snippet to reach into the compilation unit, into its list of statements, get the second statement, which is this method invocation, reach into the argument list of the method invocation to this block, reach into the block to its list of statements, reach into the list of statements to its first statement, cast that. Note that that first statement is actually a return statement because Groovy implicitly returns the last statement in a lambda, so our LST reflects that. Reach into the implicit return statement to grab the thing we're actually interested in, the use JUnit platform method invocation, and finally, cast that appropriately. Um, and then we have a brand new method invocation that we can stick into the Lambda and, of course, call a quick auto format on it to make sure that it is indented appropriately for the context it is being inserted into. And if you ever have to call auto format manually and you find that it is over indenting or under indenting the code you're asking it to format, it determines the indentation level based on the cursor you're passing it. And so that cursor should always point to the parent element of where the element you were formatting is under. So this trick, you see it here, this trick of like newing up a parser, parsing to an LST for the full document, and then extracting just the element you're interested in, both kind of teaches you something about the implementation of Java template and that this is more or less what it's doing under the hood, and equips you to operate in contexts where it is unavailable, which is not just in Gradle Groovy scripts, but in a YAML document or a properties file or an XML document, you might find yourself in a position of looking to uh, generate new LST elements to insert into these from whole cloth, and find that newing up a parser and then extracting the element of interest is the best or the most expedient way to go about that. So yeah, very very useful trick here. Oh, so cool. So yeah, this recipe I think is pretty easy to read or easy to understand what it's trying to do. Fairly easy to read, but then touches on kind of a whole host of more advanced recipe authoring topics, like decomposing one visitor into five more specialized sub visitors, overriding creating visitors that have something other than execution context as their type parameter so that you can use them for search or other purposes. How to operate within an environment where type attribution is unavailable or less reliable than it is in Java. How to, you know, deal with it when Java template or similar mechanisms are unavailable, and just kind of how to organize a visitor when there are many possibilities for where or how the subject of the recipe could be found. Uh, yeah, so I think this is a good learning example. And this guy is just in rewrite testing frameworks. So if you're curious to look at this, I can go ahead and just put a link to it in the chat. So if you want to inspect this recipe yourself, go take a look. Okay, on to kind of our next recipe, advanced recipe authoring subject is writing recipes that compose together multiple scanning recipes. And even using an individual scanning recipe has all these problems. So this is our rewrite Java dependencies. Now, those of you who have used Open Rewrite or Moderne for dependency management are probably familiar with add dependency and upgrade dependency. And if you were to go and look in the oh yeah, so I forgot I actually ran JUnit Gradle test to use JUnit Jupyter on some projects. And if we go see the result, yep, we see a lot of the configuration we were looking for getting added. So that's great. But yeah, so now onto the subject of like add dependency. If I look for add dependency, there's quite a few versions, right? There's add Maven dependency, there's add Gradle dependency, and there's add Gradle or Maven dependency, right? So add Maven dependency, fairly straightforward. Add Gradle dependency, also straightforward, and at least in terms of what they're trying to do. Uh, but in most situations, we would like to add a dependency while being completely agnostic about what build tool it's running on. So we made this other recipe which aggregates together both add dependency recipes. The challenge with these with with adding these recipes together is that they're both scanning recipes. And we've discussed scanning recipes before, but just to recap, uh, a regular recipe, uh, dependency, a regular recipe that is not a scanning recipe uh, gets to override get visitor and return a visitor that will be used during the edit phase to see all of the files in a project or their parsed LST representations one at a time and make choices about whether or not it's going to edit each of those files. And it only gets to see them once, and it doesn't receive any notification that it has seen them, that it has seen all the files in the list, for example. So anytime you need to reference information from one file in your repository and use that information, while editing or looking at some other file, a regular recipe won't cut it. It just does not have the functionality. It does not participate in the phases of the life cycle that would allow it to do that. What recipes can choose, however, to be scanning recipes, which means in addition to that edit phase that everyone gets to participate in, or all recipes participate in, scanning recipes get access to two more kind of phases of the recipe lifecycle which precede the edit phase. There's this first off, there's the scanning phase where a visitor or where the recipe can return a visitor, called a scanner, which gets to look through each of the source files but not make any changes to them, uh, and extract any information that is going to be interested in using later into an accumulator object, which the scanning recipe itself gets to define what that object looks like, what information it's going to store, and then so the scanner is a visitor which looks through all the files and populates information into the accumulator or the scanner or the info object, whatever you want to call it. Uh, that will then be available in the next two phases of recipe execution. One of which is the optional generate phase, where new LSTs can be produced, which this add dependency recipe doesn't demonstrate because it doesn't create any new files. And then that same scanner or that same accumulator is passed into the edit phase. So when editing files, you can use the knowledge gained from the scanning phase to make decisions. And so both versions, both the Gradle and Maven versions of add dependency, have to be scanning recipes because they support this only if using parameter, which is itself a powerful but not always very well understood feature of these recipes. These let you say add a dependency on whatever it is, JUnit Jupyter or what have you, uh, but only if some symbol is actually in use in the code. So when this feature is in use, you can't make a decision about whether or not to add a dependency to a Maven POM or a build.gradle file until you've looked through all of the source files and checked their types in use to see if the relevant symbol is actually used within within the project or not. And so, that's exactly what you look at the scanner here, what it does, right? If only if using, you know, is not set or it is set and that type is in use, then the relevant field on that accumulator, which is passed, from the scanner into the execution phase later, will have that value set. Uh, and along with some additional information. So in order to use this recipe from within another recipe, in that other recipe become responsible for making sure that any scanning recipes you're going to use have all the information they need to make the changes that they're going to make. So in rewrite Java dependencies, where we define the version of add dependency that adds together the Maven and the Gradle forms of add dependency, we have to do that. So this guy, because it uses scanning recipes, it also has to be a scanning recipe itself. And if you look at its accumulator, the class, the object that's going to be passed into the scanning phase and into the edit phase, it has two fields, and one is the accumulator from the Gradle visitor or from the Gradle add dependency, and one is the accumulator from the Maven add dependency. And so then in the scanning phase, the visitor, it applies, it gets, it constructs a copy of Gradle add dependency, gets its scanner, filling in the field from the wrapper recipes accumulator that is for the Gradle recipe, and ensures that it gets to participate in the scanning phase as it needs to, so that the only if using functionality will work as expected. And same for the same for Maven add dependency. And then in the edit phase, you see very much the same sort of thing happening, where the two recipes that that this uses as its implementation are their visitor is fetched, and it has to be provided with its accumulator type. But then once it is, you can just use it directly in your visitor like you would any other visitor. So we check if the whatever source file we're looking at is acceptable by this visitor, and if it is, we apply it. And so in this way, both the Maven and the Gradle visitor have all the information they need and are allowed to edit all the files in the project. So yeah, this kind of property of being a scanning recipe can kind of spread a little bit, because as soon as you want to use as an implementation detail of your recipe another recipe which is a scanning recipe, you also need to be a scanning recipe. Oh, the kitten has noticed that there's a bug on the wall, so she's eagerly hunting it. The challenges of work from home software development are myriad, and many of them are cat related. So yeah, so those are a couple or a few of the kind of more advanced recipe authoring concepts that I have found coming up pretty frequently in recipe development. These challenges of composing scanning recipes together, these challenges of being responsive to existing configuration are things that we maybe don't cover super well in our documentation, that these patterns exist or are solutions to common problems, that I wanted to share with you guys today. So yeah, let's see. I think that is everything. So yeah, hopefully that was helpful, and I hope you enjoyed and found this informative. And I will see you again the same time next week, when I believe I think Tim will be back. But whether or not Tim is back from his travels, the plan is that I will interview prominent open source community member and frequent contributor to Open Rewrite, Shannon Pam Pearl. So look forward to that. Shannon has a lot of great insights about Open Rewrite. He has fixed a ton of bugs, particularly in the Groovy Gradle parsing. So if you've ever successfully run a Gradle dependency manipulation or other recipe in a Gradle file, Shannon is probably at least partially to thank for that process having worked out well for you. So look forward to that. Uh, until next week, have a great time refactoring and modernizing your code. Bye bye now.